Hello students, today we'll talk about drift velocity of electron and relaxation time of electron. Very interesting topic and very important from understanding point of view. Let us start. We all know that in any conductor, we have positive ions vibrating about their mean position, and there are so many free electrons. Around 10 raised to 22 to 10 raised to 23 electrons per meter cube. So number density of free electrons in any conductor is very high, and what these electrons are doing, these electrons are randomly moving. So at any point of time, if you take any cross section, uh, and if you see how many charged particles are crossing the cross section, say from left to right or from right to left, the net number will be 0. And so even though you have charges moving inside the inside this conductor, you don't have any net flow of charge, so electric current is 0. Why? Because random motion is in such a way that net flow is 0. Now why these electrons are moving? Because they have thermal energy. At room temperature, all these electrons are having thermal energy, and so they move randomly. Actually, this diagram is slightly misleading because these ions are not steady, they are also vibrating, but not very much relevant from this topic's point of view, so not shown here. Now, what happens when you apply electric field? Suppose if I connect this conductor with a battery in such a way that my left side is connected to positive terminal of the battery and right side of the conductor is connected to negative terminal. What will happen to this random motion of electrons? Let us try to understand. So let us consider point A. Say some electron is starting its motion from this point, and there is no battery connected, so there is no electric field. So let the electron be starting its motion from point A, and we consider that this electron is reaching point B following this path shown by yellow line. And why it is moving? As I said, it is moving because of its thermal energy available at room temperature. Now, what will happen when I apply electric field? Suppose if you apply electric field in such a way that left side is positive and right side is negative, then I can say that electric field is going from left to right. So what will happen to this electron? Would it start going straight if this side is positive and the other side is negative? Suppose the electric field applied is like this. So do you think that electron will start going straight towards positive? No, that will not happen. The moment you apply electric field, the electron's path will be slightly altered, and instead of reaching point B, now it will reach point C, following the path shown by green line. So this phenomena is very similar to someone who is trying to cross river, and what is the effect of the river flow on the person? Suppose there is a river flowing, and someone is trying to go from, say, point X to point Y. Okay, so you start from point X and head towards point Y, but what will happen because of the flow? Because of the flow, you will not be able to reach point Y. Instead, you might reach somewhere here, say point Z. And what is the distance between Y and Z? Who determines the distance between Y and Z? It is purely determined by how much is the flow. Okay, and this YZ is called drift. More the flow, more the drift. See here, something similar is happening with our electron also. In absence of electric field, the electron would have reached point B. But what is the effect of electric field? Because of the electric field, electron did experience force F is equal to QE. Okay, and what this electron did because of the force? Instead of reaching point B, it reached point C. So I can say that this B to C is the drift of the electron. Electron experienced drift because of the applied electric field E. Okay, and the velocity corresponding to this drift is called drift velocity. Okay, and most of the time the drift velocity is of the order of few millimeter per second, but because of this drift we have electric current constituted. All the electrons in conductor experience this drift, and so all these electrons have drift velocity, and so you have resultant flow of charge in particular direction. Electrons flow opposite to electric field, and the net flow of charge is called electric current. This is how electric current is constituted. Let us try to understand expression for the drift velocity. Consider an electron of mass me and charge E. When we apply external electric field, what happens? So we know that because of the electric field, the charged particles, electrons here, experience force F is equal to QE, and so they experience accelerated motion. So if we replace F with ma, we get this equation. Okay, me is mass of electron and a is the acceleration produced. So if I make a subject of formula, a is equal to E by me. This is the acceleration produced in the electron when subjected to electric field E. Now we know from the equations of motion that velocity of any particle at time t can be given as v is equal to v0 plus at. Okay, what is v? What is v here? Velocity at time t. What is v0? Initial velocity, a is acceleration, t is the time taken. When we talk about electron, initial velocity of electron is considered to be 0. Why so? Why should I consider initial velocity for electron to be 0? Because when electrons travel from one point to another point, even during few journey, it will be colliding so many times. Actually, electrons collide 10 raised to 8 to 10 raised to 9 times every second, and the time between two successive collisions is called relaxation time, because only during that small interval of time it is relaxing itself. So it is called relaxation time. And after every collision, what happens? Now electrons are colliding with ions. Ions are too huge as compared to the electrons. So once electron collides with the ion, it transfers total its energy to the ion, and hence it will lose its energy. So its velocity will be 0. So every time when it collides, its velocity will be 0, and again it starts its motion under the influence of electric force. So initial velocity of electron is always considered to be 0. So if I substitute acceleration value in this equation of Vd, what do I get? So using equation 1 in the equation of Vd, we get E by me times tau. What is tau? Relaxation time. And this equation suggests that drift velocity depends mainly on electric field, and it is very obvious also. You apply higher voltage, you are creating strong electric field inside the conductor, and so electrons will be drifted more. Okay, so this is the expression for drift velocity of electron, and that was the topic today. Let us conclude now. So in conclusion, we can say that when electric field is applied to any conductor, the randomly moving electrons experience F is equal to QE force. And what is the direction of this force? It is opposite to the electric field. Why? Because the charge we are talking about is negative. And what happens because of that? Because of the force, electrons are dragged in the direction of force, and velocity corresponding to this drift is called drift velocity. And how much is the drift velocity? Drift velocity is denoted by Vd. It is E by me times tau. What is tau? Relaxation time. What is the order of drift velocity? Few per second. And during its journey from one point to another point, an electron collides so many times with the ions of the solid, and the time between two successive collisions is called relaxation time of the electron. And what is the order of the relaxation time? It is relaxation time is of the order of 10 raised to minus 8 to 10 raised to minus 9 seconds. So that was the topic today. Thank you.